Okay, thank you. So my name is Kristian. I recommend that you people who sit in the back, if you want to actually see what I'm doing in the vCenter when I'm doing the demo, I recommend that you come forward. But if you, but I'm not forcing you. So I will, by the end of the presentation, welcome. I will show a full demo of what we can do, but as a kind of a teaser, let's do a full recovery of a 0.5 terabyte VM here. You can see my backups are listed here in the vCenter, and I want to do a full restore of a 0.5 terabyte, 482 gigabyte VM. The recovery will start when it hits the restore window. And it was faster than I was able to show it, so it's here. So that took like 3 seconds, and that's 482 gigabytes in size. So, and that was not a snap, that was a full recovery of almost a 0.5 terabyte VM. So by the end of this presentation, you will understand how this works. How can we do stuff like that? Stuff like this, and I will show you the longer demo, how we clone, backup, move, and etc. Stuff like that. Today we are going to talk about HyperConvergence Architecture, how we make the data centers as simple as possible. And let me try to find my presentation. And here we go. Oh. Just a second. Awesome. Welcome. So my name is Kristian Salo. I'm the solution architect for SimpliVity. I've been working at SimpliVity for a little less than 2 years now. Before that, I was working for EMC for almost 10 years as a technical guy responsible for data protection, everything regarding backups, replication, archiving, stuff like that. Before that, at Sun Microsystems, and long time ago at IBM. So today we're going to talk about hyperconverged infrastructure and how hyperconverged infrastructures make the running of your data center really, really simple. Just a few words about SimpliVity as a company before we go into the actual technical stuff. So SimpliVity was founded in 2009. It's a company based in Boston area. We're a technology company, so the thing that you are going to see today, we developed that in stealth mode about 3.5 years. All the code that we are using is homegrown, made by us. We are one of the pioneers in hyperconverged architecture, and as I said, our mission is to simplify the IT. We have some premier investors, and the company at the moment is about 750 employees. By the end of this year, way over 800, so we are growing really, really fast. Some of the customers around the world, you probably are familiar with the logos. I'm not going to go through individual customers, but everything from quite small environments with 10, 20, 30 VMs to hundreds and thousands VMs. We actually have a few customers in the room. I will, if you want to talk with them after the presentation, we have really, really good customer references. Atea is running their systems on top of SimpliVity OmniCubes, and we can talk about those things at the booth also. So, company was founded in 2009. We came out with a product in early 2013, and Forbes magazine last spring told that we are the fastest company in the IT history to go from product introduction to 1 billion valuation in the industry. So we are growing really, really fast. Why are we talking about hyperconverged infrastructure? Because the reason is that because the old way of doing data centers is going away. So there's a huge change in the markets now. I could compare it to the change when VMware came, or basically when virtualized environments came to the market, that was a huge change for the way we did computing or the way we did data center. This is basically as huge change how we run the infrastructure underneath the hypervisor. So basic server markets and storage markets are quite flat or going down, and the converged infrastructures are going up really, really fast. The reason why we are using Cisco as a hardware platform is that Cisco is doing really, really well in the server markets. The OmniCube platform also runs on, we have an OEM agreement with Dell servers, so if you prefer to run those, and also we just announced in the VMware cooperation with Lenovo. So 3 server brands are available. That was about the company. I'm about the kind of marketing company stuff. I'm a technical guy, so let's get into the actual issues that we have in the data center and how we can solve them. So, as I said, the goal or the mission of the company is to simplify IT and make things a lot easier. And there was this a few surveys from companies like Goldman Sachs and IDC that kind of made these. Welcome. A lot of people coming in. So some of these companies who made these surveys regarding what is happening in the IT today. And with the Goldman Sachs survey, they came into basically the companies that are running the IT infrastructures, the IT budgets are flat, are not at least going up. So basically companies have less or flat or less money to do more things. As a technical guy, the more important kind of interesting part is that IDC did a survey. What does the administrators in the company, how do they use their week, or how do they spend their week? And they came with these numbers that about 1/4 of the week goes to monitoring and troubleshooting the platform that you are running to run your virtualized environments. Kind of finding out what's wrong, why some systems are not running up very well, etc. About 1/5 of the week goes to provisioning, patching, and doing different kinds of configuration changes, etc. Then about 15% of the time goes in meetings like this, where you are sitting and trying to figure out how to build things easier and how to make your life easier and how to run the operation as easy as possible. And about 20% it goes to opening service tickets to servers, storage, backup, networks, etc. So about 80% of the time of an IT administrator goes to kind of trying to keep this stack of systems running. And only in this review, only about 20% of the time is used for what is really, really important, like innovation and trying to make the business run better. And usually when I go to the customers and I talk with the tech guys, and they see this 20% here and they laugh at me that if I had 2% time in a week to do some innovation, that's a good week. So usually the guys are just trying to keep the system running and keep the users happy. So it is really, really hard work to run the data centers. So what is SimpliVity doing? So the vision is basically, if you think about the IT infrastructure and divide it into 2 layers. You have the layer over the hypervisor where you have management like vCenter and the orchestration tools like vRealize and Cisco UCS Director and UCS Manager and all the other orchestration automation tools. And then you have the stuff underneath the hypervisor. And in the kind of old world, the way we built data centers was that you had your servers, maybe blade servers, maybe rack servers. You had your storage switches for your SAN network or IP network, storage network. Then you had your high available storage systems. You have your SSD for those applications who need a lot of IOPSs, a lot of performance. You you have backup appliances, maybe tape libraries or deduplicating backup environments. You might have one optimization if you have several data centers and you want to do disaster recovery between the sites. Might have some storage caching and all the backup applications, etc. So this is the way most of the data centers are built today. Not all of them have all of those components, but more and more every day. And that's really, really complicated to run that. And this is the stuff that takes the 80% of the IT admins kind of weekly time, how to keep this running. The hyperconverged approach that we are doing does this in a lot more simple way. The basic idea is that all the IT infrastructure underneath the hypervisor, being it the public cloud, private cloud, or remote offices, is running on x86 platform. Basic 2-rack unit x86 server, and all the functionalities that you have here, your CPUs, memory, your storage, your backup, your one optimization, cloud gateway, storage caching, backups, file level restores, application backups, all that stuff that you are used to get from here is done with the SimpliVity OmniStack data virtualization platform. So this makes the building and running of the data center really, really simple. And a lot cheaper also. So how can we take all the functionality and bring it here? The big differentiator to all the other, there are a lot of companies who've built these software-defined data center type of approaches, and I will talk about that more about that in just a few slides. But the big differentiator with OmniStack is that inside these basic x86 servers, you have a PCI card that we call a data acceleration card. And what basically that card does, that we offload all the functionalities to that card, and we have an engine inside those systems to do all that stuff. And that's why we do it really, really fast. And we look into that, how that actually works in the next few slides. So this is what we do. This is like the high-level overview of what we do, and we do it really, really well. So we actually announced last summer what we call SimpliVity HyperGuarantee. Because of the functionality that we can bring with the data virtualization layer, we know that we can do this stuff that I'm going to present here. And this is actually in our warranty EULA. So in our guarantee, so we guarantee the following things. Compared to classical storage, including backup, like storage and backup, we promise that we save 90% capacity. If we don't do these things, you get your money back or you get more hardware from us. The second one, as an old backup guy, this is awesome. We promise in our warranty that you can back up and recover a local VM in less than 60 seconds. And that's in our warranty. I will show, and you actually, those guys who were in the beginning, I did the teaser demo, I recovered that half a terabyte VM in like 3 seconds. In the end, you will see the full demo how I do those things. Hyper simple. The only user interface we have is the vCenter. There's a plugin for vCenter where you can, like the normal VMware admin stuff, backups, restores, clones, and moves of the VMs. You can do those with 3 clicks from the vCenter. When we will support Hyper-V next year, it will be the system center. We also support KVM, but today I'm going to focus on VMware. Hyper manageable, so if you have a lot of VMs in the federation, you can create or update backup policies for thousands of VMs in less than 60 seconds. In the demo, we will do backup policies, etc. You will all get the basic admin training by the end of the presentation. And the last one, hyper available, so you can add and remove and upgrade the SimpliVity nodes online without any service, without any downtime. So these are pretty good things to promise, and this is actually in our warranty. If you go to the SimpliVity.com, go to the warranty, you can download our warranty EULA, and this stuff is there. let's take a look into the data center, what we actually do. So if we think about how data centers have evolved in the last like 15 years, and what does the hyperconverged stuff do there, and what can we offer them? So, like 15 years ago, and in some cases still, you probably remember the time when you have an application and that application had a physical server, it had its own CPU memory and storage resources. During that time it was quite, if these servers became full, it was quite difficult to get more capacity from the other servers because they were dedicated physical servers. Then in the middle of the 90s, companies like EMC and then Data General, HP, HDS, those companies came with a great idea that, hey, let's do a consolidated storage system. And now you have a pool of storage that you can dynamically share to those physical servers. Great idea. Solved a lot of problems. Then a few years later came VMware, and then the other hypervisor providers basically did the same thing for CPU and memory resources. Let's make a put a fast x86 server there and run the virtual machines on top of the hypervisor. So now you have a dynamic pool of CPU, memory, and storage that you can give to those virtual machines as they need. And then if it is a very critical environment, let's put those in the 2 data centers. So this was basically when VMware came out, this was the kind of a basic architecture of a virtualized environment. How to make your life easy and simple, everything is virtualized and you can have capacity to all the VMs very easily. And things were really easy in the beginning, when the average size of the virtual machine was like 8 gigabytes, when it was doing DNS and DHCP, all these kind of small tasks. But today, you are running virtual machine, you are running like core business operations like SAP, Oracle, SQL, emails, etc., like core stuff on the virtualized environments. So you start to have a lot of data here. And when you start to have a lot of data, you start to see problems in the stack which are related to I/O. And what I mean with this is that, and actually these problems have given birth to companies, to total companies solving these different problems. So what I mean with this, let's say that you have 2 data centers and you start to have a lot of data and you want to replicate data between sites. If you have long distances or thin pipes, companies like Riverbed came with these great ideas how to push a lot of data between thin lines with these 1 acceleration boxes. Great solution to solve this issue. Then that's one kind of I/O problem, how to get a lot of data between 2 sites. Then you had the backup problem. In the old world, when you did take backups, what it meant that if you have 10 terabytes of data here, and you have a half a year backup rotation, meaning that you would have like 4 monthly fulls, and then 4 weekly fulls and 5 monthly fulls, and then some incremental backups between. So from 10 terabytes of production data, you would have like 100 to 150 terabytes of backup data. Okay, you can get really, really fast tape libraries, but if you want to do fast recoveries, that problem gave birth to these deduplicating backup appliances companies like Data Domain that I was working for a long time. So great products how to take the production data and put it into a deduplicating backup appliance to get quite fast recoveries from these systems. And those systems have their own ways to replicate that data also. Then there's a lot of talk about public cloud. How to use public cloud for this and that, and for disaster recovery, for example. That gave birth to those cloud gateway type of systems that look like a local backup target, but you back up to the external cloud. And of course the performance problem that where you have SSD, like a spinning disk, you get 100 IOPS per spinning disk. If you need 1,000 IOPS, you need 10 of those disks. And if you need 10,000 IOPS, you need a lot of disks. So then came all these flash-only storage or flash SSD caches where hot blocks are here and the colder ones are here. And then somebody decided, hey, the best place to have SSD is actually in the same bus as the CPU and the memory. So let's put SSD inside to a PCI card and put it inside there, like companies like Fusion.io was born, etc. And then, of course, you can get SSDs into the storage systems also, and then all the backup applications and etc. etc. So, when I started at SimpliVity, one of my colleagues said, when he saw this picture, he said that he calls this picture as the accidental architecture. And I think it's a good name, because basically what happened here is that every time there has been an I/O related problem in the stack, the answer from the industry has been that don't worry, there's a box for that. So if you have a problem for replication, don't worry, there's a box for that. If you have a problem for backups, don't worry, there's a box for that, etc., etc. And all of a sudden you start to have like 15 different boxes in your rack, and your admin guys are using 80% of the week to administrate that stuff, and not doing innovation and doing stuff like that. So it's kind of little by little started to go into a really complicated systems. And let's think about this. What is the purpose of all this? It's to run a virtual machine. And keep it safe, of course, and give it performance. That's like, come on, that's really difficult way of doing a simple thing. How to run a VM fast and keep it safe. And easy to manage. There must be an easier way to do that. And there is. So the industry basically sees this as a problem. And about 6 years ago, the industry started to talk about converged architecture. So if this is the good old way of doing, good with this, good old way of doing the environment, the kind of first step to making this easier was this, about 6 years ago, they started to talk about these integrated systems, where companies like Cisco, EMC, and VMware came together and made these vBlock systems, where they built these servers and storage switches and some applications to make it easier to operate, and build these integrated systems. So the end user can choose small, medium, or large system. Also NetApp, VMware, and Cisco FlexPods. HP has some stuff like that, etc. Most of the big old guys have these. So it's a step in the right direction, but basically you are still using the same architecture. And if you think about this architecture was designed before virtualization. Like a Sun-based disk system, it is showing LANs to physical servers. And with VMware, that physical server is just ESX server. So the basic architecture is designed before virtualization wasn't even here. So the next step from here in this kind of evolution of converged architecture is the way that these big cloud players do their data centers, like Facebook, Google, Amazon. They don't have centralized storage systems. They are using basic x86 servers, and from the internal disks of those servers, they build a virtual storage that all those nodes are using. The commercial versions of this approach would be like VMware vSAN, very nice, Nutanix, Maxta. There are a lot of these software-defined data center type of systems. The kind of issue that we have here is that if you want any of the advanced enterprise type of disaster recovery type of functionalities like inline deduplication, compression, disaster recovery, backups, file level restores, in many cases they say that, okay, buy Veeam, which is a great backup product, or buy Networker or NetBackup or something, use some external backup software. If you want one acceleration between the size, buy Riverbed. So I could ask that, is this really hyperconverged when you still need a lot of that stuff to do the kind of whole stack to run enterprise applications? So what SimpliVity is doing is that we bring the whole functionality, the CPU, memory, and storage resources, the backup, single file restores, application backups, one optimization between sites, cloud gateways to Amazon, etc., storage caching, all the backup functions, everything is included here. And the big differentiator here is that these guys do it with software, so they are quite limited what they can do from here because they are using the x86 CPUs that are basically used to run those VMs. We have the engine inside all of those nodes, the accelerator card. I'm going to talk about that more in just a few slides. And we offload all the functionality from here to that card. Okay, so let's get back to this accidental architecture picture and look what does this hyperconverged architecture from SimpliVity give you in this picture. So one of the actual node, this says Cisco UCS, but it can be the Lenovo box or Dell box. But it is an app in all those three different flavors. What the customer gets is an appliance. It has everything when it comes to your site, it has everything installed. The ESXi, the data virtualization layer, the card, everything. So it is integrated before it comes to you. And if you want to know more about that, come to our booth and I'll explain how that works. So this is a basic x86 servers with CPU, memory, disks, SSD, etc. And inside that chassis, we have the data acceleration card. And what does this card do? It deduplicates, compresses, and optimizes all data at ingest, in line. When the data is born, it is deduplicated and compressed and optimized once and forever on all tiers. What does this mean? I'll explain in a few slides. And so basically, this node gives you, and now comes a lot of hype words in a row, it gives you an inline deduplicating and compressing scale-out storage. And what does that mean? If you need more capacity, you just add more of these nodes. So this gives the storage capacity, so you don't need these centralized storage systems anymore. Because we deduplicate and compress everything, so if I want to do a clone or backup or move between sites, and these sites can be like here in Tallinn and in New York. So if I want to do remote replications, we have the one optimization built in. So for remote backups, clones, moves, and stuff like that, you don't need WAN acceleration. It is built in. Actually, as a good example, we have a customer, Petrobras, which is one of the biggest oil companies in the world. They are using these systems on oil rigs in the middle of Caribbean Ocean, and they are taking full image backups over a 2 megabit satellite link to the Texas data center. We have a German customer who has a small data center in Angola, in Africa. And you can imagine what kind of network connection you have to Angola. And he can do full image backups from Angola to Germany. So it's cool stuff. So we have, everything is deduplicated, compressed. We have backup is one of the functionalities. We have full image backups, client file level backups, application level backups. Everything is included, so we don't need those external backup systems for operational backups. Everything is just safe on several local nodes, and then we back up between sites. We have cloud gateway to Amazon Cloud, and other public clouds are coming soon. We have a very, very good performance. Typically, you can get from one of these units from 15 to 45,000 IOPSs. And scalability is linear, so if you need more, you just add more of these nodes. And it's scaling, backup is included, and it is scaling horizontally. When you need more of anything, you just add more of these nodes. And this same box actually is also your ESX server. So it is, when it comes to you as an appliance, it is running your ESX version of choice. So building the data center is really, really simple. We actually have a customer in Sweden who has 52 remote sites all over the world. And they chose SimpliVity, and the reason why they chose SimpliVity was that they told us that we chose SimpliVity because of two things. One, the first thing is that they can build a full HA VMware data center with remote backups to the remote site in one day. They can put it up, full VMware data center, HA storage, remote backups to central site. They can put it up in one day. Because it's actually, you put two systems in the rack, power it on, give it an IP address, add it to the vCenter and run a deployment script. That's it. And the second thing was that they can train their VMware administrator to operate the whole data center in 1 hour. So, three things are what this data virtualization platform is built on. The first is the data acceleration card. So this is the engine, the heart of the system. So what this does, as I told you, it does an inline deduplication and compression and optimization for all data once and forever. And I'll explain, we have a few good slides to explain how it actually works in just a few minutes. We have one user interface. It's the vCenter. We don't have any other GUI. It's the vCenter, the same graphical user interface as the VMware admin is using. And also we have plugins to the orchestration tools like Cisco UCS Director and also the vRealize from VMware. So all the functionalities that we provide can be orchestrated and automated with those orchestration tools. And the third thing is that this was from the day one a built-in data protection. It's not like, okay, we built a great data center, how are we going to back this up? Okay, let's use some third-party backup application. This was built in from the day one because the idea was that this system is built to run tier 1 applications like SAP, SQL, Exchange systems, CRM systems, etc. We have in US, we have 15 towns who are running their 911, the emergency call centers on top of these. And with the built-in data protection, we can provide you 10-minute RPO. RPO means that we can do full backups of all the VMs every 10 minutes if we want, without any I/O to the system, without making load so that all the systems are going. I'll show that in the demo also. We can restore a VM in seconds. In our guarantee, we promise that that will happen in less than 60 seconds. But usually it happens in just a few seconds, etc. So, how does this system work? Take a sip of water. How much time do you have?
10 minutes.
Okay. So, the way this works is that we have it's a basic x86 server. We have CPU, DRAM, SSD, HDD, like basic x86 server. We have ESX installed on top of that, and then we have the SimpliVity data virtualization platform pre-installed already when it comes to you. And in the heart of the system, we have that card. The way that the data virtualization layer works is that we have presentation layer and we have data management layer. The presentation layer is basically what ESX sees as a storage. And then you have the data management layer where we do the data virtualization. So, let's have an example. You have the first VM here, and this VM does a write. That write, of course, gets registered as a change into the VMDK file in the data store. But what happens in the data management layer, we check that do we have this 8K block physically on the disk? If not, we compress it, so we do deduplication and compression in line and write it to the disk. Again, a new write, we check do we have that? No, we compress it, write it to the disk. Again, a new write from a third VM, we check, it registers as a change to the VMDK file, and here in the data management layer, we check that do we have that? No, we don't, we compress it, write it to the disk. But now I get a new write from the first VM. It registers as a change here. And what happens here in the data management layer, we find out, hey, I have received that 8K block from somewhere else in this cluster earlier. I do not have to write it physically to the disk. I just mark it into the metadata to the block map that belongs to both of those. Again, a duplicate write, I mark it as a change here, but here I just point it to the same block, deduplicate the block in the background. So when the systems are running, when the VMs are running on top of the data virtualization layer, they are all writing full speed to their own data stores. But what is happening actually that we only do physical write to the disk in a case if any of the VMs in these clusters have managed to generate an 8K block that we have not received from anywhere else before. So what do we get from this at this stage? We get a really, really good write performance, of course, because we want, as it says, the best I/O is, oh, it should read here, but it goes here. The best I/O is the one that you don't have to do. So we get a good write performance because we don't actually write that much to the disk. The second thing is that we get a really, really good efficiency from the storage because everything is deduplicated and compressed when the data was born. And we get a really, really good functionality for VMware administrators doing clones, backups, recoveries, etc. like this. So here I have two sites. They are in the same federation. So a VM here is block map pointing to the deduplicated blocks. So if I want to do a full backup, local backup, and these deduplicated blocks are protected on several of these nodes, which are RAID 6 protected, etc., etc. So if I want to do a local backup, I'm not doing any I/O, I'm just copying the metadata. If I want to do a remote backup, I'm just sending the block map there and checking what deduplicated blocks I have there, and moving only the blocks needed. So, as an analogy, what I usually use to explain this, let's imagine this VM is like a Lego racing car. So the block map here is like the instruction booklet, what Legos I need and in which order for that racing car to be. And the storage here is like a box of individual Legos. So if I want to do a remote backup, I'm just sending the instruction booklet there and checking what Legos I have here in this Lego box. If I'm missing the steering wheel and the rear tire of that car, then only those needs to be sent there. So this is what the data virtualization means. We actually detach the virtual machine from the physical storage, and all the operations that the VMware does, clones, moves, backups, recoveries, we are working with these block maps, not the physical data. So we only do physical I/O if it's absolutely necessary, which makes everything really, really fast. And if I want to recover a VM, I just register it to the vCenter. And it's a global, so this is a two-site environment. You can scale to a very large system. The only user interface is the vCenter, and I will show the demo next, so you will see how the vCenter. As a wrap-up, this is kind of the vision where we are. So we have the data virtualization platform. We support VMware and KVM at the moment. Hyper-V is coming. All the orchestration, basic orchestrations are there, and the rest is coming soon. We currently support Lenovo, Cisco, and our own, which is an OEM Dell. And technically, it could be any server, but those are the ones that we are supporting now. And cloud of choice. So, going from this accidental architecture to this really, really simple way of building your data center. And what does this give you? It gives you the fact that your guys have been running the 80% of the week to make this run. To make it as simple as possible, you free a lot of time to do the innovation and building the actual business processes on top of that. To make because what this does is make everything underneath the hypervisor super simple. So now I'll show you the fast demo. So let's go to my vCenter, if I find it. Okay, here we go. So here I have a vCenter. I have two data centers. There's a lot of restores because my colleague in Belgium is doing a demo in the Storage Expo in Belgium at the same time. So let's start from the top. The backup policies. This is the federation level where I see both of my data centers, the San Jose and Boston data center. I have my backup policies here, and as an example of a backup policy, we can take a look at the bronze backup policy here, and it says that please take a daily backup to both data centers and keep them for 30 days. The next rules is make a weekly backup and keep them for 3 months. And the next rules is make a monthly backup and keep them for 2 years. That's like a typical basic bronze backup policy. A platinum backup policy, as an example, is saying that on top of those that were in the bronze policy, they added here that do a backup to both data centers every 10 minutes, keep them for 3 days, both data centers every hour, keep them for 5 days, and a 4-hour backup for 1 week. And from that on, it's the same as the bronze. So you can build a really, really simple backup, like normal backup policies that to automate your backups. So let's drop from the federation level to the Boston data center level, and I will show you what you need to know about your storage. Let's say I'm a VMware admin and I need a new data store for my system. I don't have to go to the storage system and think about disk groups and RAID groups, etc., and mount that to the ESX. I just go here and say that create a data store, choose which data center I want to create it to, give it a name, choose a default backup policy for that, and then give it a size. Let's do, whatever, let's make it over not 100, like that. Let's make 100 terabytes. So within like 40 seconds I will have a 100 terabyte data store there. So it's super simple. That's all I need to know about storage as a VMware admin. The last few things that I'll show you is some of the capacity stuff. In this system I have 18 terabytes of VMs. I have 344 terabytes of local backups and 177 terabytes of remote backups coming from the other data center. And physically, I have used 6.14 terabytes. So there's almost half a petabyte of logical data deduplicated and compressed into 6 terabytes. Come to our booth, I'll explain what that means. So last thing, I'll show you some clones, moves, and recoveries. So here is my VM, and that's a half a terabyte VM. Let's make a full clone of that VM first. So this is not a snapshot, it's a full clone, and it is as fast as the original when it gets born. So here is my cloning, it is ready now. That's the clone. So that's a full clone of a 480 gigabyte VM that I just cloned it. Let's take this clone and make a full backup out of this new VM that we just generated. This is an ad hoc backup going and this is not a snapshot, this is a full backup of that VM. It's done. Let's take another VM from there and do a full recovery. Let's take that one. Restore a VM. Here goes, it's started and it's done. That was a full recovery of a half a terabyte VM. Let's take my Atea Action demo machine and I'll show you a file level restore. Let's go there. Restore files and folders. I get this wizard. I put next. I choose the template. I open the VMDeco file, then I browse into the partition where those files are. Let's recover the whole folder here, the file level restore folder. Add that there. Next. Put that to that VM. And I don't have any clients anywhere, so this is done fully in the vCenter. There's the recovery. It's in progress and it's done. So if I go to the actual console of that VM, I should have it open here. Sorry. Yes. There. Oh yeah. So let's open this a bit bigger. Scroll down just. Here we go. And what we actually do, because we don't have a client, we mount it as a virtual DVD-ROM. So you can, here is my file level restore directory, and that's the picture that was in that folder. So in that like 5 minutes, I showed you backup policies. I made a 0.5 terabyte VM clone. I made a 100 terabyte data store. I recovered a VM. I recovered single file, etc. So that, and all that happened in maybe like in 5 minutes. So I have 2 minutes, 12 seconds. Okay, I have 2 minutes for fast questions. The bigger questions that you probably have. You can come to the booth. We will be here until the end of the day. So any questions at this time? If you have questions later, please come to the booth. I will be there. I can show you bigger demo, like go deeper into that. But as a wrap up, the basic thing is why hyperconverged matters. It makes your life easier, because you don't have to operate that, you operate that, so you can focus on running the business. This is a fast and easy and a simple way of running your data center. There's a question.
Is it upgradable in terms that if you have already two separate soldiers, can I just add boxes or?
Yes.
Is it so?
Yeah.
Do I need to lay new fiber or?
No. Everything is included. So this is just one box. But what you actually do is that when you build a cluster, you just add to the same rack. These are talking to each other via 10 gig Ethernet. So it is super simple. I can add these nodes in like 5 minutes. You don't need any SAN networks. You don't need anything.
How much it costs?
Come to the booth. As a tip, I cannot give you as a tip.
How many machines the one box supports?
Well, usually it depends, because we have small, medium, and large sets. It has from 16 to 28 cores, depending on the model. So usually we say that you can run up to 180 VMs in one box.
We had some kind of answer that 50 is too much.
It depends. Yeah, of course it depends on the VM. But as a reference, Atea is running their production on these, so you can talk to those guys. We have a customer in this, a very happy customer. Do like this, please. Talk to that guy. They have been running these over a year already. And then we have the biggest deal we did in Q4 was to a service provider, 200 of these. So this is the way to do the data centers now. Okay, please come to our booth and to learn more about this. You will also, there's a nice little booklet that you can get where you have all the basic information and all the data, etc. So thank you for your time. This was everything I wanted to know today.